Hello and welcome to another series of spectroscopic methods. In my last video, I have explained about mass spec or mass spectrometry. So today I am here again with one of its very important types. It's called Maldi Tof Mass Spectrometry, or you can simply call it MALI. Stands for Matrix Assisted Laser Desorption Mass Spectrometry. So it's simply a very versatile, or you can say an adaptable technique, or you can say it is a multi-skill technique. And MALDI, as I told you, it stands for Matrix Assisted Laser Desorption Ionization. So it has something to do with the matrix. Now, what is a matrix? Matrix is actually, so you can say, selection of some organic compounds that have the conjugated pi system along with them, and they are mostly, you can say, highly conjugated in their series. They are chosen to be the ones that have the conjugated aromatic systems. They are the aromatic rings inside them, like benzene rings, and almost the same arrangement of functional groups around them. So there is a particular reason behind them for creating a matrix. Why it is called a matrix assisted laser desorption? So it has something to do with something. So let's discuss that first. As I told you, it's a matrix, so it's a matrix assisted technique. So what is matrix itself? Matrix is simply, you can say, it facilitate ionization process, and it by, you can say, absorbing the UV light, that is the ultraviolet light. It absorbs the UV visible light, right? So what are those compounds? What could be those compounds? It's the series of compounds. For example, alpha cyano 4-hydroxycinnamic acid, 2,5-dihydroxybenzoic acid, and 3,5-dimethoxy 4-hydroxycinnamic acids. These are a few examples of the compounds that are chosen to form a matrix. So all matrix molecules have conjugated rings or conjugated pi systems. These conjugated rings absorb UV light and bang the analyte to the gas phase, right? The laser energy are, you can say, absorbed by a matrix molecules, which will be energetically exertionized or cut out or ablated from the surface of the molecules, or you can say from the surface of the sample carrying the analyte molecules to simply the gas phase, right? So this is the basic function of the matrix, that it simply encapsulates the sample inside itself, and it will not let the UV rays damage the sample. So it absorbs the UV light itself. It absorbs itself. So this is one of the basic functions of the matrix, right? This technique is also called soft ionization techniques because due to the compounds not being fragmented during the process, or you can say they will be ionized as a whole and without going through the fragmentation process. So that's why they are called it's called the soft ionization process. Now during this all happens during the analysis. Now how the sample is prepared? Matrix and sample are mixed together, right, in some, you can say, miscible solvent, and the solvent is allowed to evaporate. The solvent evaporates, right, and these are placed on a steel plate. Some sort of a steel plate is there that has got some small holes over it, and those holes they will be used to settle down the sample and the matrix solvent inside it, and then the solvent is allowed to evaporate from the steel plate. After being dried, the sample is placed inside the instrument for analysis. So this is what simply happens when you are dealing with a compound that is matrix assisted. As I told you, it's a versatile analytical technique. So it detects and characterizes molecular masses of different macromolecules like proteins, like peptides, like saccharides, like nucleotides, and many other organic compounds. Or the polymeric compounds are also involved in it, that has got the polymeric chains in them. So